Good day everybody, we got an interesting question. We are expected to integrate sine of root of x positive u over root of x times e raised to the power root of x times dx. Now foremost what I wish to do is I would like to make the following substitution. Let root of x be equal to some t. Now what is root of x? Root of x is nothing but x raised to the power 1 over 2. This is equal to t. Now you differentiate both sides, you get 1 over 2 times x raised to the power 1 over 2 negative 1 multiplied with dx is equal to dt. Now this is nothing but 1 over 2 negative 1. That's going to be negative 1 over 2 times 1 over 2 times dx is equal to dt. So this in turn would mean my dt is equal to, push this negative 1 over 2 down. So this is going to be dx over 2 times x raised to the power of 1 over 2, which is rewritten as dx over 2 times root of x. So this is what I've got. Now take this and look for the quantity, but apparently I see in the question I do have dx, I do have root of x, but I do not have 2 there. So I just take the 2 out and I write it as 2 times dt is equal to dx over root of x. Okay, so this is what I have got. So therefore this integral is rewritten as sine, in place of root x I have t, and this u is a constant. Okay, this is divided by dx over root of x. Dx over root of x is 2 times dt. I'll write the 2 there. I'll place the dt here. Now you got e raised to the power of root of x. Root of x is t. Now this is equal to 2 times integral e raised to the power of t multiplied with sine of t plus u times dt. Okay. Now what I would like to do, I would actually apply integration by parts. So that would mean you will have to take u. Now I am going to be applying the substitution by utilizing the Lie logarithmic first, inverse, and then algebraic, trigonometry, and then you have exponential. So u is going to be sine of, because trigonometry comes before algebraic, before exponentials, right? So it's going to be sine of t positive u, and my dv is e raised to the power of t times dt. So you integrate this, you get v is equal to e raised to the power of t. Fair enough. You differentiate this, you get du is equal to cos of t positive u times differential of t, that's dt. So the formula is uv negative integral v du. This is what you have got. Now on the left hand side you have integral u dv, right? So let me write that u dv. So this is going to be u dv. This is u, integral of u is sine of t positive u. My dv is e raised to the power of t times dt. This is equal to u is sine of t positive u, and then my v is e raised to the power of t negative integral v is e raised to the power of t. My du is this cos of t positive u times dt. Okay, now what I would like to do here is this, I have this quantity, right? So before we could apply integration by parts, I'm going to state here, let I be equal to integral e raised to the power of t sine of t positive u times dt. Don't worry about the 2, we will deal with that later. So this is the assumption, or this is the consideration I am taking, and then I am applying integration by parts, and then I am getting this. Now this is actually I, right? So you got I is equal to this entire quantity e raised to the power of t times sine of t positive u negative integral e raised to the power of t cos of t positive u times dt. Now you have to apply integration by parts for this. So I would say consider integral e raised to the power of t cos of t positive u times dt. So my dv is e raised to the power of t dt, my v is e raised to the power of t, my u is cos of t positive u, my du is negative sine of t positive u times dt. So you substitute over here, so you get I is equal to e raised to the power of t sine of t positive u negative u times v, that's going to be e raised to the power of t cos of t positive u, uv negative integral v du, so e power t, du is, you have a negative sign, so this is sine of t positive u times the dt. You have a negative sign, this will become positive. Now you have to actually distribute the negative sign. So I is equal to e raised to the power of t sine of t positive u negative e raised to the power of t cos of t positive u negative integral e raised to the power of t sine of t positive u times dt. Now what is this? This is the consideration that we started off with. So this is going to be I, right? Negative I. So you bring this, you get 2I. So let me use the next sheet of paper. So this is going to be 2 times I. 2 times I is equal to e raised to the power of t sine of t positive u negative e raised to the power of t cos of t positive u, right? So 2 times I is got. Now go back here. Now what is this? This entire thing is I. So you have here 2 times I. So take that value and substitute it here. So if I were to take this as sum 2, so substitution will come over here. So therefore 2 can be rewritten as, this is equal to e raised to the power of t sine of t positive u negative e raised to the power of t cos of t positive u. Now we assumed, right, what is the assumption? If you go back here, we assumed that t is equal to root of x, so reverted. So this is equal to e raised to the power of t times sine of t positive u negative cos of t positive u. Since t is equal to root of x, this can be rewritten as e raised to the power of root of x times sine of root of x positive u negative cos of root of x positive u, positive arbitrary constant. See, this is the solution for this question, right? It's a beautiful question. Thank you everybody. Please like, share and subscribe to our channel.